Assalamualaikum warahmatullahi wabarakatuh. My name is Intan Hidayah binti Abdul Rashid. Today I will present about my final year project entitled Converting Pineapple Peel into Activated Carbon via microwave assisted with phosphoric acid for cation dye removal. I am supervised by Dr. Ali Jawad. So, this is the content for my presentation today. Without further ado, let's jump to the first chapter in this topic. It basically have three main topics, which is the biomass waste, phosphoric acids, and cationic dyes. For biomass waste, it's referred to the biodegradable organic waste that can degrade. In this study, I used the pineapple peels as a biomass waste, which can pose a significant environmental challenge. Secondly, due to the excessively growth of the algae, these biological microbes can cause disturb to the ecosystem. For phosphoric acid, it is clear and odorless liquid. If it spills out on a surface, it can cause corrosion. The example the use of the phosphoric acid is in the cleaning industry as a rust remover. Next, the dye is a colored substance that chemically adheres to the object that is applied to. Meanwhile, the cationic dyes refer to the dyes that can dissociate into positively charged ion in the aqueous solution. In industry, cationic dye functioned as a dye in various material. For this study, I used the methylene blue as a cationic dye. Now, we move to the problem statement. The first problem statement is the prevalence of the cationic dyes in the industrial wastewater, which can pose a significant concern due to their adverse effect on ecosystem and the human health. The second problem is inadequate management of the solid biomass, specifically in the pineapple peel waste, which is no economical value and suffer in landfills disposal. Also, excessively growth of the algae could cause environmental impact too, because they will releasing the toxin and can make harm to the ecosystem surrounding. The significance in the study is to eliminate the water pollutant from the industrial effluents due to the impact of the cationic dye contaminated. The second significance is to reduce the solid waste accumulation that can cause a disposal challenge in the landfills. And the third is to provide eco-friendly adsorbent to absorb the dyes from the wastewater. Okay, now we move to the next slide, which is objective. First is to convert biomass waste of pineapple peels and algae into activated carbon using microwave assisted with phosphoric acid activation. The second is to investigate the influence of the microwave assisted with phosphoric acid activation on the production of the activated carbon, focusing on the pore structure and absorption properties by SEM EDS, FTIR, and SRD analysis. The third is to evaluate the absorption efficiency of the activated carbon for the removal of the cationic dyes from water. We move to the next chapter, which is literature review. Microwave-assisted activation method for biomass conversion for dye applications. According to Sharma, Dangi, and Shukla in year 2018, dyes may contain toxic heavy metals, carcinogenic compounds, and the textile dyes, along with numerous other industrial pollutants, pose high toxicity levels and have the potential to be carcinogenic. Secondly, according to the Nur Ashah Rosli et al. In year 2023, activated carbon provide an economically viable and environmentally friendly alternative to traditional carbon sources. Meanwhile, for the study conducted by Fu and Hamid in 2012, activated carbon derived from pineapple peel pose high surface and a well-developed pore structure, making it effective for absorption applications. Then the study that conducted by Xin Hu et al. In year 2012, microwave irradiation is valued for its ability to provide rapid and homogeneous heating at the molecular level, which is enabling quick thermal reaction. Okay, now we go to methodologies. From the raw material, I impregnate 1 to 2 material with the phosphoric acid. Then I put under the oven condition. For drying process, I put it into the microwave for 600 watts for 50 minutes for optimum condition. Then I wash it until it reached the neutral, and after that I grind and filter it until it reached the constant particle size. After that, I use several characterization processes such as SEM-EDX for structure, and then FTIR and SRD for absorption properties. Next, I apply it into BBD optimization and PHPZC. Now, we go to the result and discussion part. For first characterization, I use SEM-EDX to analyze about the microstructure and the pore characteristic of the materials. SEM-EDX stands for Scanning Electron Microscope with the energy dispersed X-ray spectroscopy. Based on the result, the figure of before show that it has crack and porous. Then after the absorption, the crack become flattened because it's already filled with the dye. Element on both results shows that the percent of carbon atom was increased. Meanwhile, the other element shows decreased percent of atoms. There is also an addition of sulfur after absorption of the dye. This is because the sulfur-containing compounds might be present in the dye's molecules. For the second characterization, we use Fourier transform infrared spectroscopy, or we call FTIR. It used to identify the chemical bond in a molecule and to study about the absorption properties on the adsorbent. From the graph, it showed that FTIR analysis of the activated carbon and the activated carbon after absorption. In summary, the observed peak in the FTIR spectrum of the activated carbon after absorption suggests the presence of the hydroxyl groups, carbon-hydrogen bond, carbonyl groups, carbon-fluorine bonds, and the bending vibration of the carbon-hydrogen bond in a pineapple peel algae sample. Now, we move to the X-ray diffraction characterization, which is to investigate about the crystallographic structure of the materials. The graph displays about the sample after the absorption of the methylene blue, reduced peak in intensity, which is semi-crystalline. The existence of the amorphous structure in the range of 22 degrees can result from the restructuring of the carbon bonds. In this study, the existence of the amorphous material is good because it has higher surface area and improved porosity, which can be advantageous for absorption application. For PHPZC study, this sample lies at the value of 5.2, so that the surface charge of the material was negatively charged. Since the methylene blue is positive charged because of the cationic dyes, so it attracts the adsorbent, which is negatively charged surface, and it can be related with the maximum electrostatic attraction. For application, I use the Box-Becken design as the adsorbent optimization. There are 70 runs was observed regarding to their doses, pH, and time. For the highest methylene blue dye removal is the run 4, which bring the color removal of 99.07%. From the ANOVA, the model F-value 133.89 implies all elements of the model is significant. Besides that, the lack of fit F-value of 2.26 implies that it is not significant due to the pure error. Specifically, the model has significant statistical power, and it is acceptable in investigation because the elements of the model have p-value of the less than 0.05. From the graph, the data obtained lying closely to the diagonal line indicate the significance of the chosen factors and the accuracy of the assumption. This is the 3D surface for the three significant interaction between time, pH, and dosage. The significant interaction between dose and pH shows that removal of the methylene blue increased from 8.5% to the 98.8% by increasing the pH of the solution from 4 to 10, besides increasing the dose from 0.02 gram to 0.1 gram. Meanwhile, the significant interaction number 2 is between dose and time. The removal of the methylene blue increased by extending the contact time to 70 minutes. And the significant interaction between pH and time can be increased the pH of the solution from 4 to 10, besides extending the contact time to 70 minutes. Next, we turn to the conclusion. converting pineapple peel and algae into activated carbon assisted with phosphoric acid was performed, and it was applied for removing the methylene blue dyes from the water. BBD test was applied to investigate the factor of three independent variables, which is dosage, pH, and contact times of the removal of the methylene blue. Number 3, the optimal condition obtained for methylene blue removal were 0.1 gram of the adsorbent dose, pH solution of 7, and absorption time of 70 minutes. Number 4, all the objectives achieved and the actual result was accurate, comparable with the prediction result from the software. This is the reference from my citation. That's all for me. Thank you for lending me your eyes and ears.